I'll be telling you about large applications practicum. In this lecture, we are going to look at tools and techniques for testing your code. Specifically taking an example from Java, I will be showing you what are the different types of testings we can do, what is a unit test, and how do we perform such kind of testing in the code. Testing becomes very important for large applications to make sure that they do not have errors and bugs in them. And testing is also a way of developing software, which is also referred to as test-driven development. So let's get started. So software testing has a motivation that coders love to code but hate to test. Software testing is considered as a waste of time, energy, resources, but that is not so true. Software testing is the process of verifying and validating that a software program application product meets the business and technical requirements that guide its design and development. And, of course, the software works as it is expected to work. It is an investigation conducted to provide stakeholders with the information about quality of the product and the service under test. So software testing is a very important field and it's an important area, but one should not have the feeling that coders love to code but hate to test. So there are two terms which keep occurring in the software engineering process, particularly related to software testing, and these two words are verification and validation. So verification is the process of evaluating a system or component to determine whether the product or a given development phase satisfies the condition imposed at the start of the phase. So we start out by asking the question, have we built the software right? So verification happens several times in the coding process. We define what we need to code, we code, and then we check whether what we have coded satisfies the conditions which we had imposed at the start of coding process. Have we built the software right? In contrast, validation is the process of evaluating a system or component during or at the end of the development process to determine whether it satisfies specific requirement. That is, it is what the customer wants. So validation asks the question, have we built the right software? So validation is also done occasionally, but validation is to kind of see whether the software meets the requirements of the customer and have we built the right software. And it is a process which is more done at the end of the software process or development. So software testing can never completely identify all defects within the software. Even if we develop numerous test cases, there is a chance that we may not be able to test everything in the software. Instead, software testing furnishes basically what we call as a criticism or comparison that compares the state and behavior of the product against oracles like specifications, contracts, comparable products, past versions of the same software product, inferences about intended or expected purpose, user or customer expectation, relevant standards, applicable laws, etc. So the idea is a comparison between the state and behavior of the product against already set standards like specification, contracts, and comparable products. So it is like what the system does and what it is supposed to do. And that is basically what is called as software testing. So this particular thing shows that if defects in the software is found earlier, it is cheaper to fix it. So it basically the illustration below states that if the problem in the requirements is found only post-release, then it would cost almost 10 to 100 times more to fix than if it had been already found by requirements review. Right? So if it was caught in the requirements, then hardly there is any cost, architecture, construction. But if it was found post-release and we need to do everything again, then it might cost 10 to 100 times. So there are two types of testing. One is called the functional testing and the other is called the non-functional testing. Functional testing typically refers to activities that verify the specific action or functions in the code usually found in the code requirements document, what each function is supposed to do. Can the user do this, or does the particular feature work? The non-functional testing refers to the aspects of the software that may not be related to specific function or user action, but it may be related to, say, scalability or security, and tends to answer the question, how many people can log into at once? What is the security, scalability, or the ET of the code? There's another concept which is between static and dynamic testing. So typically things like reviews, walkthroughs, or inspections are considered as static testing. We do not run the code here. We just test the code based on static review without operation. Pencil and paper kind of reviews. Cost effective it is. What some of you did in software engineering class, if you have taken such a course, actually executing the program or code given a set of test cases is referred to as dynamic testing. In this class, particularly in this course, I will be teaching you dynamic testing, which takes longer time but might catch bugs because we actually test the code with inputs and outputs, and actually we will also be looking at things like code coverage, which ensure that all parts of the code are tested properly. So there is a box approach for testing, and generally the box approach is divided into three particular parts, which is referred to as the white box testing first, which is where the tester has access to the internal data structure and algorithms, including the source code and that implement these, and then the tester would write unit test cases, particularly where he will define the inputs into the program and the outputs expected from the program, and then would also look at code coverage, mutation testing, and other types of things. So white box testing is when you have the source code available to you and you can test the source code by running the code against inputs and outputs which are expected. The other is black box testing, which is treating the software as a black box. Typically you have an executable file without any knowledge of the internal implementation, and you can specify inputs and outputs and do boundary value analysis, specification based testing, where you do not have access to the source code but an executable file which you can run to test the software. And then we have the gray box testing, which involves having knowledge of the internal data structures and algorithms for the purpose of designing test cases, but still testing is done at a black box level with the executable and example reverse engineering to determine, for instance, boundary values or other error lists. So gray box means that we are having knowledge of the internals, but we will still use the black box approach for testing. Testing is also done at different levels. Typically, the unit testing test and verify functionality of a specific section of the code, usually at the function level or at the class level in an object-oriented environment. It ensures that specific individual functions or modules is working as expected and does not verify the integrity of the whole software. In contrast, integration testing that verifies that interfaces between components against the software design, tries to expose defects in interfaces and interaction between integrated components, example modules. And then regression testing, focusing on finding defects after major code change has occurred, uncover software regressions, old bugs that have come back. So the idea is we test the software, then we make changes, and then we test the software again to make sure that what has been updated does not break what was already existing before. So there are different models, particularly of software development. One famous model is the traditional waterfall model. Testing is performed by an independent group of testers after functionality developed before it is shipped to the customers, and everything happens in a sequential manner. We start out doing analysis, then design, then coding, then testing, and then delivery of the software. But we only do it once. In contrast, most recently we have started using the agile or the extreme programming development model, which is more flexible, which is basically what I was telling you at the start of the lecture, has something called the test-driven development model. And here, unit tests are written first with inputs and outputs, and typically which are expected to fail initially, but as code is written, it passes incrementally largest portion of the test suites, and the test suites are continuously updated as failure conditions and corner cases are discovered, and they are integrated with any regression tests that are developed. So idea is we write unit tests, we write asserts where we give inputs and we run those inputs on the code, we get an output and we compare the output with the expected output, and they're expected to fail initially, but over time when we improve the code, we're expected to get success. So these are the references I used to create the lecture. There are some references on unit testing, some references on Eclipse browser, which I'm going to just show you. And there are other JUnit test cases for writing unit testing cases. TCL-EMA is a code coverage tool, which we will learn how to rate and use. I acknowledge the help of the TAs for creating this lecture. So let's get into the activity for this lecture, where we are going to use Eclipse browser, Eclipse editor to test a piece of Java code which has been given to you in the activity, and then also check code coverage in that particular tool. So here, first we need to install Eclipse, and Eclipse can be installed by going into the browser and writing Eclipse download, and you will come to the Eclipse page of the Eclipse Foundation. It's free software, and you can hit this button and download the file. And once you download, you will get a download in Eclipse, and this download can then be double clicked. So you will get a download like this, and you can double click it to install it. And once you have installed it, you can start your Eclipse by going here on the prompt and in the search and writing Eclipse. And here is my Eclipse, and you can see it's already open and it is running right here. So once you have installed Eclipse, we need to install a few more things before we can do the activity. So the next is that we need to install, of course, we need to create a Java project. So for that, you can actually go here and you can actually do new, and in the new you can hit Java project, and it will configure a Java project for you, and you can name this Java project JUnit EMA demo without the ports, and then hit finish. One other thing you need to do is you need to be able to install the Java development kit. So there is a link given. You can actually go to this website, and if you go to this website, the JDK 23 is available, and you can go to Windows, for example, if you're using Windows, and you can install this MSI installer. It will again download a JDK, which is Java development kit, which allows us to configure Java in Eclipse and install it. And once you've installed it, there is already a source code given to you in this activity. So let me show you where it is. So this is a weak file, this is the activity, and this circle is given to you. So remember that when Eclipse installs, it uses a folder for its work, which is called the workspace. So in my case, it is installed in HP. It will show you the path, and this is the Eclipse workspace. So inside, I have already created this project, and inside the source folder, I need to unzip the circle folder, which is given to you in the activity. And as you can see, the circle folder has two files, circle.java and circleconverter.java, and both files are useful to run the source code. In addition, there is a module info.java which is created in the folder by Eclipse. In module info.java, you need to write a line require java.desktop on Windows machines, because it might be required for running the circleconverter.java, which is a Sphinx application, Java Sphinx application. It is used to create the GUI. So once you have installed this, you need to install the ECL-EMA as well, which is a code coverage tool. And for that, you can go into help, you can go into Eclipse Marketplace, and here you can search for, in the search window, once it loads up, it takes a minute or two to refresh its packages. You need to write ECL-EMA in the find, and you will see the ECL-EMA code coverage package. And you can see I have already installed it, and therefore it is coming as installed. Otherwise, for you it will come installed, and you have to hit install and finish. So this is installation of the entire package. One more thing is that to be able to use the JUnit, you need to be able to install the JUnit. So for that particular purpose, you need to go into the folder, the project folder in the package explorer, and then right click it, and then you can open properties, and inside the property go to Java build path, libraries, and then choose the module path and add external jars. And then you can see that I have already given you JUnit 4.1 as the JUnit package, which you can install for Java unit testing, and then apply and close. And you can see my JUnit 4.10 is already installed. So now with this, you are ready to do this activity. And one interesting thing is you can run this code by hitting this play button. And when you hit, you get a pop-up and you get a menu like this. And this menu is giving you a radius. And if I enter some radius and I hit the enter key, it gives me the area. I can clear it. If I make the area and I hit enter key, I get the radius. So it's basically calculating the area of the circle from the radius, or from the area of the circle, the radius. So this is the application. This GUI has been created in Swings, and you can learn about it. We are going to see how this tool works to actually test the application. And here you can see there is some code coverage analysis coming, that 76.1% of the code was run. All these lines which are green are run, the yellow have been partially run, and the red has not been run at all. So we're going to look at code coverage in more detail as to what it means. So with this, I would request you to do your activity and see you in the next lecture.